Is your washer displaying an LE error code and you can't figure out why? Well, this is our Parts Doctor, and today we're going to figure out how to diagnose it. These instructions also apply to some Kenmore models that were manufactured by LG. These Kenmore models have 796 as the first 3 digits of their model number. If an LE error code is displayed on your washer, it means that the tub is failing to spin or the motor isn't able to operate correctly. A common cause of this error is simply overloading the washer's tub and putting too much strain on the motor. Another common cause of the LE error code is an object getting stuck in the tub and preventing it from being able to spin freely. Turn off power to the washer and check around the entire front and rear edges of the tub for any coins, hair, or debris that may be stuck. The washer's tub should spin easily when rotating it by hand. If you've overloaded the washer or found an object preventing the tub from being able to spin, fix the issue, then unplug the machine for up to 5 minutes for the washer to reset the LE error code. After 5 minutes, plug it back in and run a wash cycle. If you check both of these things and the LE error code still displays, it may be caused by a bad motor component including the stator, rotor, hull sensor, a power issue with the main control board, or wiring harness. In this video, we'll show you how to diagnose and test each of these components. Caution: some of these tests require working with live electricity. Be extremely careful when performing these tests. When working inside the washer, be careful as it has sharp edges. To start the diagnostics, open the washer's door and see if the tub of the washer spins freely by hand. If the washer's tub is not spinning, you must track down that problem first. Now, we'll test power coming from the main control board. For this test, we'll need access to the back of the washer. For this repair, you'll need to disconnect power and water to the washer. On the back of the washer, use a Phillips head screwdriver to remove the 4 screws holding the back panel to the washer. Next, lift the back panel till the bottom retainers are free. Then, lower the back panel to free the top retainers and set it aside. Locate the mid-junction on the motor wiring harness. First, make sure the washer is unplugged. Then, peel back the plastic to access the mid-junction. Then, insert one of the multimeter probes into the white wire on the mid-junction box. Next, insert the other probe into the gray wire on the junction. When setting up the test, it is important to make sure that the probes do not touch each other, as it will cause a short. Then, turn the multimeter to the DC voltage setting. This will look like a V with a straight line and a dashed line above it. Then, reconnect power to the washer. Next, press the power button on the washer, but do not press start. This should give you a reading on the multimeter between 10 to 15 volts of direct current. Now we'll run a DC voltage test to check the motor wire harness and Hall sensor. We'll show you how to test each individual component later in this video. First, make sure the washer is unplugged. Then insert one of the probes into the gray wire on the mid-junction box and the other probe into the blue wire. Then reconnect power to the washer and press the power button, but do not press start. Then slowly spin the rotor on the washer by hand. When spinning the rotor, you should get a pulsing reading on the multimeter that reads up to 10 volts of direct current, or 10 VDC. Once you've completed this test, you will then want to run this test again, but move the probe from the blue wire to the red wire. Then repeat the test. If either of these tests fail to pulse up to 10 VDC, the Hall sensor or motor wire harness is bad. Now we'll remove and inspect the rotor assembly. For this repair, you'll need to disconnect power to the washer. Using a 17mm socket, remove the bolt holding the rotor in place. When removing this bolt, we suggest removing it with an impact drill. If you do not have an impact drill, you can remove it by hand, but you will need to hold the rotor by hand and use a jerking motion to break it free. Or, if possible, have someone hold the basket in place. Next, slide the rotor off of the washer. You may need to wiggle it from side to side to get it to slide off, as there are magnets on the inside of the assembly. With the rotor removed, check to make sure that the magnets are intact and not damaged. Then inspect the teeth in the center of the assembly. These teeth are part of the rotor assembly and they are not sold separately. If any part of the rotor assembly is damaged, it will need to be replaced. Now we'll remove the stator assembly and hall sensor to test the resistance. Using a 10mm socket, remove the 6 bolts holding the stator assembly in place. Next, gently slide the stator off of the washer, being careful as it is still connected by an electrical connector. Then, gently depress the retaining tabs on the electrical connectors to remove them. Then, using a flathead screwdriver, gently lift on the retainers on the inside of the stator assembly to remove the hall sensor. Using a multimeter, turn it to the ohms setting. Then, test the stator assembly by using the probes to test between pins 1 and 2, 2 to 3, and 1 to 3. Each of these readings should be between 5 to 15 ohms. If any of these readings are out of range, the stator should be replaced. Now, before testing the hall sensor, we need to identify the 5 pins on the connector. Pin 5 is the pin on the far end closest to the edge of the hall sensor, and pin 1 is the closest to the center of the sensor. Next, to test the hall sensor, you'll need to insert one of the probes into the multimeter into the 5th pin of the hall sensor and the other into the 1st pin. The multimeter should give a reading of around 10,000 ohms. Then, repeat this test on pin 5 and pin 2. They should test around 10,000 ohms. If either of these tests fails, the hall sensor may be bad and should be replaced. The final test we'll run is the continuity test on the motor wiring harness. For this repair, you'll need to disconnect power to the washer. This section of the wiring harness is most likely to have damage or corrosion, as when the tub moves, this section of wiring also moves. To test this, you'll need a multimeter turned to the continuity setting. For example, first we'll test the continuity between the white wire on the hall sensor connector and the white wire on the mid-junction connector. The multimeter should beep, showing continuity for the wire. Continue testing each wire on the hall sensor connector. Then run the same continuity test on each of the colored wires between the stator plug and the blue junction connector. If any of these wires test bad, you should replace the whole motor wiring harness. If you need to purchase any of these new parts, you can check out our website, partsactor.com. We'll leave a link in the description below. You want to make sure that you're searching with the model number from the tag on your washer to make sure you get the correct part. And that's it for today's video, and if you found this video helpful, make sure to leave a like and comment down below, and for more videos like this, please consider subscribing.